Although we can only measure differences in energy and entropy, a quick glance at any thermodynamic table will show that we routinely assign a value of the entropy to standard states. How is it that we can calculate the absolute entropy of a given state? As we did with the energy, we're going to define a reference state for the entropy. Let's think about what the most logical reference state would be. Since we know from the second law that entropy is always increasing, there must be a state with the minimum possible entropy. If we assign this minimum entropy state to have zero entropy, that will be our reference state. The state with the lowest entropy will be the one with the least number of microstates. Remember that temperature affects the number of microstates that are available to a system. So at lower temperatures, the system does not have enough energy, enough kinetic energy, to access microstates above the ground state. In fact, if we restrict the temperature to 0 Kelvin, absolute zero, then in fact the only state available to the particles will be the lowest possible state, or the ground state. And so at 0 Kelvin, the number of microstates available to the system is equal to 1. All particles are in the ground state, and so the Boltzmann entropy is equal to 0 because the natural log of 1 is equal to 0. And so we can define the system at 0 Kelvin, in which case all particles in the system will be frozen in place, and thus we have a perfect crystalline system as our zero of entropy. This statement is what is known as the third law of thermodynamics. If we use this as our reference state, so 0 Kelvin, and we look at any other state not at 0 Kelvin, and then we calculate the change in entropy from 0 Kelvin to that final state, then we are going to take the entropy of the final state, subtract the entropy of the initial state, which is at 0 Kelvin, and that's going to give us the entropy of the final state. But since this reference state is defined as having 0 entropy, minus 0, and therefore that change in entropy will be equal to the entropy of the state that we're interested in. And that's how we obtain an absolute entropy, the actual entropy of the state, from a change in entropy. When you look up standard state entropy values in the back of the book, you will see these absolute entropies, not a delta, but the actual entropy. And these are these third law entropies calculated for a change that's done at 1 atmosphere pressure, which makes it standard state.